Lists are like containers that can hold multiple items at once. Instead of creating separate variables for bread, milk, and eggs, we can put them all together in a single list. By the end of this lesson, you'll know how to create lists, access items, change them, and even slice portion of items from the given list. Let's begin with the basics, creating a list. Think of it like writing down a shopping list before going to the store. Here is an example. Shopping underscore list in square bracket, bread, comma, milk, comma, eggs, comma, apples, comma, coffee. Each of the items are strings, so you should put them in quotation. Then print shopping underscore list. Therefore, here we created a variable called shopping underscore list. Inside the square brackets, we added 5 items separated by commas such as bread, milk, eggs, apples, and coffee. When we run the program and print it out, Python shows the whole list on the screen, just like reading your paper grocery list. Now, how to get a single item out of our list? That is called accessing items from the list. That's where indexing comes in. Think of it as saying, what are the first and third items on my shopping list? Here is the example. Print shopping underscore list in square bracket 0. Another example, print shopping underscore list in square bracket 2. Python starts indexing from 0 up to n minus 1, where n is the total number of elements in the list. That means the very first item is at position 0. To get an item, we use square brackets with its position number, shopping underscore list in square bracket 0. That is the first item in the list, that is called bread. So position 1 gives us the second item, and position 2 gives us the third item, and so on. In our example, shopping underscore list in square bracket 0 gives bread. Bread is the first item in the list, found at position 0 or index 0. And shopping underscore list, square bracket 2 gives eggs, which is the third item in the list. Normally, we count from the front of the list, starting from 0 up to n minus 1, where n is total number of elements. But sometimes it is easier to start from the end to backward. Python lets us do that with negative indexing. For example, if you want to get the last item and you don't know how many number of items you have in the list, so you can simply use print shopping underscore list in square bracket -1. That represents the position of the last item, and 0 represents the position of the first item. Here, -1 means the very last item, which is coffee in our case. And if you want to get the second last item, you can use shopping underscore list in square bracket -2. -2 means the second to last item in the list, which is apples in our case. Think of it like unpacking groceries. Usually the last thing you packed is the first thing you take out of the bag. A list isn't fixed. You can change its contents anytime, just like updating your shopping list. For example, let's replace one item and see what happens. Shopping underscore list index 1. Index 1 is the second item in the list, and that is called milk. And wanted to update or change this item by another item called almond milk. Then you can print out to see that the item is updated or not. print shopping underscore list. Here, we replaced milk with almond milk, as you can see on the screen. Notice that only this one item is changed, while the rest of the list stayed the same. This shows how flexible lists are. Sometimes you don't need the whole list. Maybe you only want the first few items. That's when slicing comes in handy. For example, we can use the colon to select a portion of our list. Print shopping underscore list in square bracket colon 3. Here, the square bracket colon 3 means start at the beginning from position 0 and go up to, but not including position 3 or index 3. So we get bread, almond milk, and eggs. On the other hand, we can print shopping underscore list 2 colon. 2 colon means start at index 2, that is the start index, and go all the way to the end. That gives us eggs, apples, and coffee. Slicing lets you grab exactly the part of the list you need without touching the rest. Sometimes you don't want every item in a list. Maybe you want to skip some portion of the list. Python lets you do this with stride. Stride is the number of steps Python takes. It goes through the list and you specify it with 2 colons. For example, if you want to get every second number from the given list of numbers, here is an example. Numbers in square bracket 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. From these numbers, you want to get every second number. Print numbers double colon 2. Here, double colon 2 means start at the beginning from position 0 and take every second item. For example, the first item is 1 and the second item for this is 3 and the second item for 3 is 5. The second item for 5 is 7. The second item for 7 is 9. And the second item for 9 is not exist. So it stops here at 9. Therefore, the output is 1, 3, 5, 7, and 9. Think of it like flipping through a photo album but only looking at every other picture. Another example, getting every third item in a list of fruits. Here's list of fruits such as apple, banana, cherry, mango, orange, grape, and strawberry. Then, if you want to get every third item from this list of fruits, print fruits. Previously, we used double colon 2 to get every second element, but here we want to get every third element, so we use 3. This prints every third fruit item from the list of fruits, starting from the very beginning, index 0, that is apple. Then the third element for apple is mango. Then the third element for mango is strawberry. Therefore, the output are apple, mango, and strawberry. Imagine you have a basket of fruits and you only want to pick every third one. That is exactly what stride does. Here is another example. Reverse the to-do list. Assume you have a list of tasks such as homework, laundry, cleaning, shopping, and exercise. Then you wanna reverse the tasks from the end to the first. You can use print tasks double colon then -1. Since -1 is used to get the last element, here the stride is a -1 which tells Python to go backward from the end to the first. This prints the list in reverse, such as exercise, shopping, cleaning, laundry, and homework. It's like reading a to-do list from the bottom to the top instead of the usual order. Another example, every second number in reverse. That's the same. You just change -1 to -2. That's the same like getting every second element in positive side, but that's the reverse from the last to the first. So we take an example of the list of numbers we defined here and print numbers :(-2). It starts from the last element 10. Every other number is 8, 6, 4, 2, and 0. This prints out 10, 8, 6, 4, 2, and 0. Every second item, but starting from the end. It's like walking backward on a number line and picking every second step. Therefore, a stride works even when you don't start at the beginning. It lets you pick items in a custom pattern. By using stride, you can skip items, reverse a list, or create custom patterns with very little code. Lists can be combined, just like merging your fruits list with your vegetables list. For example, we have a list of fruits such as apple, banana, and mango, and also have list of vegetables such as carrot and spinach. Then we wanna just create a grocery cart. You can combine two lists together using plus operator. Fruits plus vegetables and a store in grocery_cart. Then you can print out grocery_cart. Here, using the plus operator, Python joins the two lists into a single bigger list. The output is then apple, banana, mango, carrot, and spinach. Think of it like putting all your fruits and vegetables into the same grocery cart. Now everything is together and easy to manage. Of course, sometimes you change your mind and remove something from the list. Python lets you delete items by their index. For example, use the DL keyword with the index number, DL grocery_cart in square bracket 1, that is the index of the item in the grocery cart list, then print grocery_cart. Here, we removed the item at index 1, which was banana. The rest of the list stayed the same. Lists can even contain other lists, which is very useful for structured data, like a weekly meal plan or a movie schedule. For example, let's create a weekly meal plan where each inner list represents a day's meals. Meal plan, then create outer square bracket, then inside the square bracket, create another square bracket, and in that square bracket, create list of items such as pancakes, salad, pasta. Consider these are a single item for the outer list represents Monday, comma, another list item, omelette, sandwich, rice. Assume this is Tuesday. You can add more, it is up to you. Then print meal_plan in square bracket 0 and add another square bracket 0. The first index selects the day, for example, Monday, and the second index selected the meal for that day. So meal_plan square bracket 0 and 0 gives pancakes, that is Monday's breakfast. And another meal_plan 1 gives sandwich, that is Tuesday's lunch. So this is called a nested list. You can create list inside another list. Nested lists let you organize complex data in a simple way instead of creating separate lists for each day. And that's Python lists in action. We learned how to create lists, access individual items, modify them, and slice them to get exactly what we need from the given list. Lists are flexible, powerful, and you'll use them all the time in your real-world Python projects. Thanks for watching.